Hi there, I'm Ryan Paul Lafler, the founder and chief data scientist for Premier Analytics Consulting, LLC. Today, we're here to showcase some of our visualization technologies for NOAA's flood mapping products. One of the flood mapping products comes from the visible infrared satellite imagery, the VIIRS One-Day Flood Composites. We'd like to showcase some of our two-dimensional maps and three-dimensional, fully interactive environments to better visualize the effects of climate change on certain demographics, to understand the socioeconomic factors that are impacted by climate change, and so that users can better understand the risks of flooding in their area in a three-dimensional approach. We'd first like to start by visualizing a typical two-dimensional topographic map. We've tiled several of these rasters, composited them together to make a nice map of the entire United States. And what this shows is in red it shows severe flood risk, yellow, orange, moderate, green, light flood risk. Any area that's blue is existing water, and any area that is a tannish brown shows land cover. Well, with the power of Google Earth Engine and its parallel processing capabilities, we were able to look at over 240,000 unique census block groups, small geographies that contain anywhere from 600 to 3,000 people, and display them on one map with this flood data. Our goal with this is to better understand the socioeconomic impacts of these flooding events and to understand existing areas that are at risk all across the United States and the globe that are susceptible to the effects of climate change. And what we're showing with this two-dimensional map is we have the 240,000 shapefiles, the unique geometries, the raster flooding map, all in one interactive product that the user can search, query, and interact with to get a better picture of the flooding risks for every single day. And these are one-day flood map composites. Let's take a look at some of the demographic data that we're working with. This is looking at an age group, the percentage of 18 to 24-year-olds all across the U.S. We're just zoomed in specifically to San Diego County. One of our major areas of interest is understanding the effects of different climate variables with socioeconomic factors. And with the power of Google Earth Engine and its tile system capabilities, we're able to visualize for every single one of these individual census block groups demographic data, socioeconomic data for it. Turning to some of our three-dimensional maps, instead of looking at things from the two-dimensional perspective, which is great if you want a nice, convenient tool, let's take a look at fully immersing ourselves in the data. What this data is looking at is a three-dimensional perspective, not just a top-down, but something where the user can zoom in to a certain location and view the terrain, the elevation, the surrounding environment around them. What this map shows is the same flood data. Notice that we still have the areas of existing water and then the areas of flood inundation, overlaid on top of satellite imagery provided by Google with an elevation map that shows the extent of terrain, how tall it is, the surrounding environment. So now we've merged these two products together to create one application that can be displayed in any web browser. And we're not just limited to just one small area. With our system for optimization, we're able to create the entire world with these 3D tiles and overlay the flood data for it. Let's take a look at Central California. Jump in here. All the user has to do is just scroll to this location and see, wow, there's a lot of flooding happening right here. And then they do some research. Our next phase is building an application that will help storytell these results, an interactive storytelling of what happened in this area. And if you've been studying some of the events in California these past few months, we've had a lot of precipitation, a lot of rainfall. Well, what happened is that this is called Tulare Lake. Over to the east, there are some very tall mountain ranges, and that's where a lot of snow accumulation has accumulated. Well, over time, as it's warmed up, all the drainage from these mountains over here has led to the reemergence of dormant lakes in central California, one of which can be seen here. So this has so much purpose when it comes to agriculture, when it comes to detecting the risk of flooding in certain communities, understanding seasonal trends, historic trends, and the reemergence of these dormant lakes, and also looking at significant storm events. For example, hurricanes that form off the Gulf of Mexico coast, or other types of significant storms. With the power of this technology, we can fully render and model three-dimensional environments to get a better understanding of how flooding occurs in communities all across the globe. The final product that we'd like to show is the same three-dimensional view, but now looking at the flood map overlaid with the demographic data. Do you remember that 18 to 24-year-old two-dimensional map that we showed? Right here. Well, now this is visualizing that same map in the three-dimensional space. And you can see, looking at this for San Diego County, here's our typical top-down perspective. But now, let's see the effects of the environment. Let's take a look at this large cluster of purple. And again, we're looking at census block groups. Well, this large cluster of purple right here is San Diego State University. So this is where a lot of young adults reside. They live in dormitories. Here we have a lot of demographic data to show that. And in addition to modeling the natural environment and the terrain, we're also incorporating human development, buildings, shapefiles from OpenStreetMap that can give us a measurement and a way of looking at the impacts on human development from these climate events. This is looking at buildings in downtown San Diego. And as you can see, we have information when it comes to elevation. We can also use this when assessing the impacts on residential neighborhoods, commercial zones, industrial zones, to truly understand the effects of climate change on these areas. And then finally, we're incorporating modern tools in machine learning and deep learning to better understand the risks and the boundaries of these flooding events. One of which is a segmentation model that we're fine-tuning and optimizing to detect the boundaries of flood events. So as you can see, this is looking at the same raster that we looked at in Central California, but instead of just looking at pixels, now we're having it segmented to draw boundaries around these flooding events. From visualization to modeling to analysis, our goal is to better study the effects and the impacts of these climate phenomena and extreme events on our communities, on our neighborhoods, not just in the US, but in a global perspective. We'd like to thank you for your time and, of course, listening to this showcase and demonstration of our products. Thank you, and have a wonderful day.